Cartesian product of three sets. Cartesian product of three sets is also similar how we did it for two sets. So let us define it, where A, B, C non-empty sets and Cartesian product of three sets A cross B cross C can be written as set of all ordered triplets A, B, C such that whereas A is from A, B is from B and C is from C. So this is how we denote the Cartesian product of three sets. It is denoted as A cross B cross C and the ordered triplets is written as A, B, C, whereas A is from A, B is from B and C is from C. Let us see this more clearly with an example. I will consider the three sets A, B and C and we will write the Cartesian product for the three sets. We will consider the three sets A as 0, 1, B as 0, 1 and C as 0, 1. First what we have to do is we have to write the Cartesian product for A cross B, then we have to do it cross product with C. So let us do A cross B. A cross B can be written as 0, 1 cross 0, 1. So A cross B equals to set of all ordered pairs 0, 0, 0, 1, 1, 0, 1, 1. So first we have to write A cross B. Now with this set of all ordered pairs we have to cross product it with C. A cross B cross C. So we'll write this pair first 0, 0, 0, 1, 1, 0, 1, 1. Cross. Now we will write the set C. C set is 0, 1. So now we have to do A cross B cross C. This is similar like how we did for two sets. How we have to do is we have to consider the first pair in A cross B. We have to pair it with two elements in the C set. How to do that? 0, 0, 0. Next, this pair with the second element 0, 0, 1. So similarly for all other pairs we have to do it. So moving on to the second pair 0, 1, 0. Next 0, 1, 1. Next we have to do it with the third pair 1, 0, 0, 1, 0, 1. Similarly with the last one it is 1, 1, 0. The last one is 1, 1, 1. So this is called as Cartesian product of three sets. In the first problem we have to find A cross B, A cross A and B cross A for various sets of A and B. For the first set we have to find all these three things is A equals to 2, minus 2, 3 and B is represented as 1, minus 4. We will find out these three things for the sets A and B. So we will start off with A cross B for this set. A cross B, A value is 2, minus 2, 3 cross B value is 1, minus 4. How to write A cross B? A cross B is a Cartesian product. It can be written as set of all ordered pairs. So first taking element 2, pairing it with all the elements in B. 2, 1, 2, minus 4. Next taking the second element minus 2, 1, minus 2, minus 4. Next taking the third element 3, 1 and 3, minus 4. So we have found out A cross B. Similarly we have to find out A cross A. What is A cross A? A cross A is we have to do it with set A into the set A itself. So A set is represented as 2, minus 2, 3 cross product with the same set 2, minus 2, 3. So A cross A can be written as the set of all ordered pairs as 2, 2, 2, minus 2, 2, 3. Next taking the second element, pairing it with all the elements in the set B, minus 2, 2, minus 2, minus 2, minus 2, 3. Next, finally, taking the last element from the set A and pairing it with the all the elements in the set A itself. 3, 2, 3, minus 2, 3, 3. So we have found out two subdivisions for this sets A and B, which is A cross B and A cross A. Finally, we have to find out B cross A. So the third subdivision for this set is B cross A, and which can be written as B equals to 1, minus 4 cross A set is 2, minus 2, 3. So now we have to do the Cartesian product of B and A. So B cross A can be represented as 1, 2, 1, minus 2, 1, 3. Always keep that in mind. We should not change the order of an element. Next, minus 4, 2, minus 4, minus 2, minus 4, 3. So we have found out all these three things for the sets A and B. And we'll move on to the next set of A and B. Second subdivision, it is given as A equals to B equals to P, Q. What does it mean? The set A also represents the elements P and Q, and the set B also represents the elements P and Q. And for these two sets A and B, we have to find out A cross B, A cross A and B cross A. We'll do one by one. First subdivision, A cross B, P, Q cross P, Q. So it can be written as A cross B equals to P, 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 Q, Q, P, Q, Q. Moving on to the second subdivision, A cross A, which is again P, Q cross P, Q. So we'll get the same set of ordered pairs for A cross A, which is P, 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 Q, Q, P and Q, Q. Next, we are moving on to the third subdivision, B cross A. B cross A will also be the same because B also has the element P, Q. P, Q cross P, Q will get the same set of ordered pairs. B cross A is equals to P, 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 Q, Q, P, Q, Q. So this is the three subdivisions for the sets A equals to B equals to P, Q. We have found out all these three things. Next, we will move on to the next subdivision. Now A value is given as M, N, and the set B is an empty set. As I already told you, any set cross product with an empty set will be an empty set. We will go one by one. First, we have to do A cross B. Now if you see, A has a set of elements M, N, whereas B is an empty set. We cannot do a cross product between a non-empty set and an empty set. Therefore, the outcome will be an empty set. Next, we will move on to the second subdivision, A cross A. A cross A can be written as M, N cross M, N. So, A cross A can be written as M, N, next N, M, N, N. The second subdivision is also over, and finally we will do with B cross A. Again B cross A will be empty. Why it is so? Because B is an empty set. Doing the cross product with an empty set will also be an empty set. So set B is empty into A set is M, N, and the outcome will be an empty set. So we have proved A cross B, A cross A and B cross A for three different sets of A and B. The second problem is given as set A equals to 1, 2, 3. It is directly given, whereas B set is not directly given, and we have to frame it using the hints given. And to write the set B, what is the hint given is X such that X is a prime number less than 10. So the B set has to be framed with the prime numbers which are less than 10. Okay, then what is a prime number? A number which can be divided by itself and 1 is called as a prime number. So we'll frame it the set A. Set A is given as 1, 2, 3. We'll frame set B, which is nothing but x such that x is a prime number less than 10. So what are all the prime numbers less than 10? 2, 3, 5 and 7. Because prime number can be divided only by itself and 1. So now we have to find A cross B and B cross A for these two sets. You all know it is easy to find. Only the one thing we have to do is we have to frame the set B in this problem. Now we will find out A cross B. A cross B can be written as 1, 2, 3 cross 2, 3, 5, 7. So A cross B is set of all ordered pairs of 1, 2, 1, 3, 1, 5, 1, 7. So we took 1 and paired with all the elements in B. Next we will take 2, we will pair it with all the elements in B. 2, 2, 2, 3, 2, 5 and 2, 7. Similarly, we will take the element 3 from set A and pair it with all the elements from set B. So 3, 2, 3, 3, 3, 5, 3, 7. So we found out A cross B for this set. Next we have to find out B cross A. B cross A is equals to 2, 3, 5, 7 cross 1, 2, 3. So we will write set of all ordered pairs for B cross A, which can be written as, first take 2 from B, pair it with all the elements with the set A. 2, 1, 2, 2, 2, 3. Next take an element 3 from B, pair it with all the elements 3, 1, 3, 2, 3, 3. Next take the element 5, 1, 5, 2, 5, 3. And finally taking an element 7 and pairing it with all the elements from the set A. 7, 1, 7, 2, 7, 3. So we have found out A cross B and B cross A for this problem. Next we will move on to the third problem. Third problem, the question given to us is B cross A is equals to set of all ordered pairs minus 2, 3, minus 2, 4, 0, 3, 0, 4, 3, 3 and 3, 4. From this we have to find out the values of A and B. We saw the similar problem in examples also. Similarly we will find out A and B from this B cross A. But one thing we have to keep it in mind, which is here it is given as B cross A, which means in the set of all ordered pairs, the first element represents the elements of B and the second element represents the elements of A. Since it is given as B cross A, then what will be the value of A from this? 3, 4. These are all repetitions. So A set as an element 3, 4, and what all the elements of B? It will be minus 2, 0 and 3. So value of A is 3 and 4 and the set B is minus 2, 0 and 3. Next problem given to us is set A equals to 5, 6, set B is 4, 5, 6 and set C is 5, 6, 7. We have to show that A cross A, which is equals to B cross B intersection C cross C. This will prove one by one. First we will prove the left hand side, which is A cross A. So A cross A equals to 5, 6, cross product it with 5, 6. So we will write the set of all ordered pairs 5, 5, 5, 6. Next is 6, 5, 6, 6. So left hand side we got it as A cross A as like this. Next we will find out the right hand side. We will check whether the left hand side values and the right hand side value is equal or not. To find out this, RHS is given as B cross B intersection C cross C. We will go one by one. As I told you, we have to finish within the brackets portions first. Then we will prove the we'll do the intersection portion. So B cross B can be written as 4, 5, 6 cross product with the same set 4, 5, 6. So what is B cross B? 4, 4, 4, 5, 4, 6. Next 5, 4, 5 comma 5, 5 comma 6, 6 comma 4, 6 comma 5, 6 comma 6. Next is C cross C. C cross C is 5, 6, 7. Cross product it with same set 5, 6, 7. What will we get? C cross C is equals to 5 comma 5, 5 comma 6, 5 comma 7. Next 6 comma 5, 6 comma 6, 6 comma 7. Next 7 comma 5, 7 comma 6, 7 comma 7. Next what we have to do is we have to take the intersection for B cross B and C cross C. What it will be? We have to take the intersection between B cross B and C cross C. B cross B intersection C cross C. What it is intersection is we have to take only the common elements from both the sets. What are all the common elements present in this is 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. The four set of ordered pairs which are common in both the sets are 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. Now we will check whether left hand side and the right hand side are equal. Yes, it is, because A cross A has the same set of ordered pairs 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. So therefore LHS is equals to RHS, hence proved. So the fifth problem given to us is set A, set B, set C and set D. Four sets are given and we need to check whether the left hand side is equal to the right hand side. We will verify whether it is equal or not. So first we will take the left hand side. Left hand side it is given as A intersection C cross B intersection D. First what will we have to do is we have to finish the brackets portion, then we will do the cross product. First A intersection C. A set is 1, 2, 3. Intersection set C is 3, 4. Intersection means we have to write only the common elements present in both the sets. So A intersection carries only the number 3 which is common in both the sets. So A intersection C equals to 3. Next we will do B intersection D. B intersection D can be written as 2, 3, 5 intersection 1, 3, 5. So again the elements between element which is common in both B and D will occupy this B intersection D, which are 3, 5. Next we will do the cross product between these two, A intersection C and B intersection D. So A intersection C cross B intersection D, which is 3 cross 3, 5. So now we will do the cross product. So which will give us 3, 3, 3, 5. So left hand side we got it as set of ordered pairs 3, 3 and 3, 5. We have to check whether the right hand side is also the same. If it is same, we can conclude the answer is true. So moving on to the right hand side, A cross B intersection C cross D. First we will finish the brackets portion. A cross B, set A 1, 2, 3 cross set B 2, 3, 5. So A cross B will be 1, 2, 1, 3, 1, 5. Next 2, 2, 2, 3, 2, 5. Next 3, 2, 3, 3, 3, 5. So we have completed A cross B. Now we will do C cross D. Then we will take the intersection between the two. C cross D will represent it as C set is 3, 4 cross D set is 1, 3, 5. Cross product between these two sets will give us the set of all ordered pairs as 3, 1, 3, 3, 3, 5. Next 4, 1, 4, 3, 4, 5. So we have to find the intersection between the both A cross B and C cross D. So A cross B intersection C cross D, which is intersection between this and this. So intersection means we will take only the common terms from these two. What are the elements that is common in both the terms? 3, 3 is common and 3, 5 is common. Only 3, 3 and 3, 5 is common. So A cross B intersection C cross D is 3, 3 and 3, 5. What is the left hand side we got? The same, 3, 3 and 3, 5. Therefore, the given problem is true. We have verified LHS is equals to RHS. Next is the sixth problem. In this problem also, A it is we have to frame with the hint, and B value, B set also we have to frame. C set is directly given, which is 3, 5. Verify 3 options. In that, the first option is this. One by one we will do it. So A can be written as 0, 1 because whole number starts with 0 and is less than 2, 2 is not included. So A is a set of elements 0 and 1. Similarly, we will do it for B. B is x such that x is a natural number such that x varies from 1 and 4. 1 is not included but 4 is included because it is here less than and here it is less than or equal to. Therefore, 1 is not included and 4 is included. So B equals to 2, 3 and 4. Next, C set is directly given, which is C equals to 3, 5. Now we will verify the first option with the sets A, B and C. We will start off with the left hand side. Left hand side is A cross B union C. So first we will complete the portion within the brackets. So we have to finish B union C. B set is 2, 3, 4. Union C set is 3, 5. Union means we have to write all the elements in both the sets. Therefore, B union C equals to 2, 3, 4, 5. Next, we have to cross product B union C with A. So, A cross B union C. Set A is 0, 1. Cross B union C is 2, 3, 4, 5. Now, we have to write A cross B union C 0, 2, 0, 3, 0, 4, 0, 5. Next 1, 2, 1, 3, 1, 4, 1, 5. So we have completed the left hand side. We have to check whether the same answers we get it for the right hand side. So moving on to the right hand side. Right hand side, it is given as A cross B union A cross C. So we will do it one by one. First we will complete A cross B. A cross B is set A is 0, 1. Cross set B is 2, 3, 4. So A cross B will be 0, 2, 0, 3, 0, 4. 1, 2, 1, 3, 1, 4. Next, moving on to the A cross C portion. A cross C is, first we will write the set A 0, 1 cross set C 3, 5. Taking the cross product between the two sets, we will get the set of ordered pairs as 0, 3, 0, 5, 1, 3, 1, 5. Now next what we have to do is we have to take union between A cross B and A cross C. Between these two we have to take the union. Since we all know union means we have to write all the terms in both the cross products. So A cross B union A cross C. So what all we get, we will write it in order. So the order goes in such a way 0, 2, 0, 3, 0, 4, 0, 5. Continuing in the same way 1, 2, 1, 3, 1, 4, 1, 5. Now we will check whether the left and right hand side are equal. 0, 2, 0, 3, 0, 4, 0, 5, 1, 2, 1, 3, 1, 4 and 1, 5. Therefore, left hand side is equal to right hand side. Hence, it is proved. Next, for same set of values A, B and C, we will find the second subdivision. So, with the same sets A, B, C, we will find out this second option. We will continue with the left hand side and we will check it with the right hand side. Left hand side, it is given as A cross B intersection C. First, we will complete the portion within the brackets. B intersection C is 2, 3, 4 intersection 3, 5. Therefore, B intersection C equals to, we have to write only the common element between the sets B and C, which is only the common element between the sets B and C is 3. Only 3 is common in both the sets. Therefore, B intersection C is 3. Next, we have to cross product it with A. So, A cross B intersection C. A set is 0, 1. Cross product it with 3. A cross B intersection C would be 0, 3 and 1, 3. Now what we have to do? We have to check whether the right hand side is also the same. Moving on to the right hand side, first step it is A cross B intersection A cross C. So A cross B is 0, 1 cross 2, 3, 4. Cross product between A and B. A cross B equals to 0, 2, 0, 3, 0, 4. 1, 2, 1, 3, 1, 4. Next, similarly, A cross C, 0, 1, cross 3, 5. A cross C will be 0, 3, 0, 5, 1, 3, 1, 5. What is the next step we have to do? We have to find out the intersection between A cross B and A cross C. What is an intersection? Intersection means only taking the common elements between those two cross products. So, A cross B intersection A cross C. What are all the common elements in two cross products? 0, 3 is common. And what else is common in both? 1, 3. Only two set of ordered pairs is common in A cross B and A cross C, which is 0, 3 and 1, 3. Left hand side also we got the same set of ordered pairs 0, 3 and 1, 3. Therefore, left hand side is equals to right hand side, hence proved. We will move on to the third subdivision. So, third subdivision, what we have to prove is A union B cross C, which is equals to A cross C union B cross C. So, similarly, we will prove the left hand side first, then we will move on to the right hand side. We will check whether both sides are equal. On the left hand side, it is given as A union B cross C. What is A union B? A union B equals to union between the two sets A and B. We have to write all the terms present in A and B. So, which will yield us 0, 1, 2, 3, 4. So, A union B is 0, 1, 2, 3, 4. We have to cross product it with the set C. So, A union B cross C. 0, 1, 2, 3, 4 cross C set is 3, 5. So, we will write the set of all ordered pairs A union B cross C, which is equals to 0, 3, 0, 5. Next 1, 3, 1, 5. Next 2, 3, 2, 5. 3, 3, 3, 5. 4, 3, 4, 5. So, left hand side we got in such a way. We have to check whether the right hand side is also the same. Right hand side, first we will complete it with A cross C union B cross C. We'll take A cross C. A cross C will be, A set is 0, 1, cross C set is 3, 5. Cross product between these two will yield us 0, 3, 0, 5, 1, 3, 1, 5. Next, we'll move on to B cross C. B set is 2, 3, 4. Cross product it with C set 3, 5. We'll get the cross product of B cross C as 2, 3, 2, 5, 3, 3, 3, 5, 4, 3, 4, 5. What we have to do next is we have to take the union between the cross products A cross C and B cross C. We have to take the union between these two cross products. So taking it so, A cross C union B cross C, which is equals to, we have to write all the terms in both the cross products since it is an union. We'll write it in order so. So we'll get it as 0, 3, 0, 5. Next would be in order 1, 3, 1, 5. In order, what will be the next term? 2, 3, 2, 5. 3, 3, 3, 5, 4, 3, 4, 5. So we got the right hand side in such a way. We have to check whether the left and the right are equal. I guess it is. So 0, 3, 0, 5, 1, 3, 1, 5, 2, 3, 2, 5, 3, 3, 3, 5, 4, 3, 4, 5. So both the sides are equal. Hence left hand side is equals to right hand side. Hence proved. Last problem of exercise 1.1. Seventh problem. In this problem it is given as A is represented as set of all natural numbers less than 8 and B is represented as set of prime numbers less than 8. C is represented as set of even prime number. We have to verify two options. First option I have written it here. We will prove one by one. So we have to frame the sets A, B and C and we have given with a hint. So A set can be written as, with the hint, A is given as set of all natural numbers less than 8. We know that natural number starts with 1 and it must be less than 8. Therefore, 8 is not included. We have to write it from 1 up to 7. 1, 2, 3, 4, 5, 6, 7. Because A is the set of all natural numbers less than 8. Since it is less than 8, 8 is not included. We have to start it with 1, end it at 7. Next, B can be written as set of prime numbers less than 8. So prime numbers less than 8 it is 2, 3, 5 and 7. Next, for constructing C, we have given with the int set of even prime number. We have to write only the even prime number. Even prime number is only 2. So we have framed the sets A, B and C with the given hints. Now we will prove the problem. We have to verify whether the left hand side is equal to the right hand side. So we will take the first left hand side, A intersection B cross C. A intersection B is 1, 2, 3, 4, 5, 6, 7. Intersection B value is 2, 3, 5, 7. We have to see the intersection between the sets A and B. Intersection is, we have to take only the common terms between the two. What are all the common terms between the two? 2, 3, 5 and 7. So A intersection B gives us a value as 2, 3, 5, 7. Next we have to cross product this with the C set. What is the C set? It is 2. Now we have to take the cross product between A intersection B and C. A intersection B cross C, which is equals to 2, 2, 3, 2, 5, 2, 7, 2. Now we will prove the right hand side and check whether the both sides are equal. So right hand side is A cross C intersection B cross C. So A cross C is, the set A is 1, 2, 3, 4, 5, 6, 7. Cross C set is 2. We have to take the cross product between the sets A and C. It will give us 1, 2, 2, 2, 3, 2, 4, 2, 5 comma 2, 6 comma 2, 7 comma 2. Next what we have to do is similarly we have to find out B cross C. What is the set B? 2, 3, 5, 7. Cross product it with C, 2. B cross C will give us 2 comma 2, 3 comma 2, 5 comma 2, 7 comma 2. Now what we have to do is we have to take the intersection for these two cross products A cross C and B cross C. Intersection means we have to take only the common terms present in both the cross products. Let us see what are all the common terms present in both the cross products are. 2 comma 2 is present in both. Next, what is the ordered pair common in both the cross products are 3 comma 2. Next 5 comma 2 and 7 comma 2. Now let us check whether the left hand side is also the same. Yes, it is, because 2 comma 2, 3 comma 2, 5 comma 2, 7 comma 2. Therefore LHS is equals to RHS, hence proved. In the second subdivision, what we are given with is A cross product it with B but not C, which is equals to A cross B but not A cross C. We will prove this subdivision. As usual, we will start off with the left hand side. The left hand side given to us is A cross B but not C. What will we do? We have to complete the portion within the brackets, then we have to cross product it with A. So for that we have to first find out B but not C. How to find B but not C? First we will write the sets B and C. B set is 2, 3, 5, 7 but not C set is 2. So how to find B but not C value is the common term which is present in both the sets we shouldn't consider. 2 is common in both the sets, so we shouldn't consider 2. The remaining elements in the set B will represent B but not C. Therefore, B but not C value is 3, 5, 7. Now, next what we have to do is we have to cross product it with A. A cross B but not C. A value is, that is the set A is 1, 2, 3, 4, 5, 6, 7. Cross product it with 3, 5, 7. So let us do this. A cross B but not C, which is equals to 1 comma 3, 1 comma 5, 1 comma 7. 2 comma 3, 2 comma 5, 2 comma 7. 3 comma 3, 3 comma 5, 3 comma 7. 4 comma 3, 4 comma 5, 4 comma 7. 5 comma 3, 5 comma 5, 5 comma 7. 6 comma 3, 6 comma 5, 6 comma 7. 7 comma 3, 7 comma 5, 7 comma 7. We should now check whether the same elements we are getting it for the right hand side. So in order to do that, we will go step by step. Right hand side it is given as A cross B but not A cross C. So what will we do is we will find A cross B first. A cross B is between the cross product between A and B. 1, 2, 3, 4, 5, 6, 7. Cross product it with 2, 3, 5, 7. So what is A cross B is 1 comma 2, 1 comma 3, 1 comma 5, 1 comma 7. Continue in the same way. Do it for 2, 2 comma 2, 2 comma 3, 2 comma 5, 2 comma 7. Next with the 3, 3 comma 2, 3 comma 3, 3 comma 5, 3 comma 7. Next pair it with 4, 4 comma 2, 4 comma 3, 4 comma 5, 4 comma 7. Next 5 comma 2, 5 comma 3, 5 comma 5, 5 comma 7. Next with the 6, 6, 2, 6, 3, 6, 5, 6, 7. Next with the 7, 7, 2, 7, 3, 7, 5, 7, 7. So now what we have found is only A cross B. Next we have to find A cross C. Then we must have to do A cross B but not A cross C. So next what we have to find is we have to find A cross C. A cross C is 1, 2, 3, 4, 5, 6, 7. Cross product it with C set 2. So it will give us A cross C as 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2. So thus we have found A cross C. Now what we have to do is we have to use this cross product and this cross product, that is A cross B but not A cross C. We have to find out this. For that I will write all the terms present in A cross B but not A cross C. We will do that A cross B but not A cross C. So first what are all the elements present in A cross B is all these things which we will write it 1, 2, 1, 3, 1, 5, 1, 7, 2, 2, 2, 3, 2, 5, 2, 7, 3, 2, 3, 3, 3, 5, 3, 7. Next is 4, 2, 4, 3, 4, 5, 4, 7, 5, 2, 5, 3, 5, 5, 5, 7, 6, 2, 6, 3, 6, 5, 6, 7. Next is 7, 2, 7, 3, 7, 5, 7, 7. So this is the value of A cross B, but not we have to write product of A cross C, which is this 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2. So now we have to find out this, which is A cross B but not A cross C. So which means the common terms present in both the cross product we shouldn't consider. Okay, so first we will strike the common terms which are present in both the cross product. 1, 2 is common, so we will not use it. Then what else is common? 2, 2 is common, we will not use it. Next 3, 2 is common, we shouldn't use it. 4, 2 is common, so we shouldn't use it. 5, 2 is common, therefore we shouldn't use it. 6, 2 is common, we shouldn't use it. And 7, 2 is common, we shouldn't use it. So the remaining terms we'll write it and we'll check whether the left hand side and right hand side are equal. So we'll write the remaining terms which is present in this A cross B but not A cross C. So the remaining terms are 1, 3, 1, 5, 1, 7, 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, 4, 3, 4, 5, 4, 7, 5, 3, 5, 5, 5, 7, 6, 3, 6, 5, 6, 7, 7, 3, 7, 5, 7, 7. So this is the right hand side we got. We'll check whether now both the left and the right are equal. Let us do it. 1, 3, 1, 5, 1, 7, 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, 4, 3, 4, 5, 4, 7, 5, 3, 5, 5, 5, 7, 6, 3, 6, 5, 6, 7, 7, 3, 7, 5, 7, 7. So, the left hand side is equal to the right hand side, hence LHS equals to RHS, hence verified. In today's class, we saw what is an ordered pair and what is a Cartesian product of 2 sets and 3 sets, and the problems based on these Cartesian product. We have completed examples and exercise problems of 1.1. I hope you all understood all these problems. If you have any doubts, please post your questions in the comment box. In the next class, we'll study about the concepts of relations and functions. Thank you.